So the last type of naming slash formulas for this unit is on acids. And what you'll notice is there's going to be two types of acids. And when we talk about acids, the simplest definition is that they are compounds that produce hydrogen ions in water. And if you follow this definition strictly, they must be aqueous. However, I'm just going to tell you this right now. You may want to write this down because this will help you for the test. The easiest way for you to tell on the test is you already have so much else to worry about, is that on the test, if it starts with an H, it is an acid. So you don't have to worry about the aqueous or not aqueous on the test. All you have to worry about is if it starts with an H. I mean, it could be H2 or something, but if it starts with an H, it's going to be an acid. And the first type of acid is called a binary acid. And it's binary because bi means two, which means that there's only two elements. So when you have these, you have H and something else, and it's typically a halogen element. There can be some other ones, but not usually. And what you do is you use this little thing here, and you just kind of fill in the blanks. So to indicate that it's binary, all binary things start with hydro. So if it says acid and it doesn't start with hydro, then you know it's not this type of acid. So what you do is you say hydro, you look at the other element, you shorten it up for the root, and then you call it an ic acid. So if we look here, we have hydrogen and chlorine. It starts with an H, so you know it's an acid. It's only two elements, so you know it's binary. So you've all heard this before, but this is hydrochloric acid, which is your stomach acid. And like we said, technically it is different than HCl as a gas, because it does behave slightly differently. But on the test, that's not what we're focusing on. We're focusing on, can you write the names and the nomenclature. So again, if you see HCl on the test, it's an acid. If we look at this guy down here, it starts with an H, so it's an acid. It's definitely binary because of the just H and just Br. So we're going to follow this trend right here. And what we have this guy is, this is hydrobromic acid. And then the only other thing you really have to worry about with mineral acid or binary acids is going backwards. Again, the clue with binary acids is the hydro. So if it says it's an acid and it starts with hydro, that is your clue that it's going to be binary. So it's hydroiodic acid. It starts with an H, and you say, okay, iodic, what did that come from? What element did that come from? And you probably all get that it's coming from iodine. So that's Hi. Now, when you write your formulas, you do need to check your charges. Hydrogens +1, iodides -1. So they are balanced, but they're not always going to be. So you do have to just make sure you check that to make sure that you have it written correctly. The other type of acid is called an oxyacid, and you have an H, still going to start with H. You're going to have oxygen, and you're going to have something else. And this is going to be, the name is going to depend on the polyatomic ion present. Let me just move that then so you can read it. So these all have polyatomic ions, and what you're going to do is you're going to find out the polyatomic ion that's in them, and if you ate an acid, you would go ic, and that's what you're going to change your ending to. And what you'll notice, another thing here, is there's no hydro in the name. So that's your clue that it's a oxyacid versus a binary acid. And then once you change the name, you just say whatever acid. So if we look here, this is definitely an oxyacid. We have H, and then we have N and O3. So you have three elements. What we need to look up is NO3. So that is nitrate. Oops. Now it's mad at me. If you ate it, you ick it. So this guy is going to be called nitric acid. If we look at our second guy down here, same thing. It's definitely an oxyacid. It starts with H, has oxygen in it. So you look up NO2. NO2 is nitrite. If you ate it, you us it, I guess. So nitrous acid. Again, notice in both cases, no hydro. The hydro is only reserved for the binary. These two down here, one thing you'll notice is we do this guy. It's definitely an oxy acid, has oxygen in it, starts with H. So you look up SO3. SO3 is sulfite. Well, if we would just change it, it would be sulfus acid, and it's kind of hard on the tongue. So if you look up here, the one thing they do say is instead of just having sulf, they say sulfur, and instead of just having phos, they say phosphor. So instead of sulfus acid, what they typically say is sulfurous acid, and it's a little easier for your mouth to deal with. And then this guy at the very bottom here is definitely an oxy acid, starts with an H, has oxygen in it. SO4 is sulfate. Same rules apply, it would be sulfic. And again, just to make it a little easier, they add the sulfuric, and you've probably all heard of sulfuric acid before. Going backwards, again, you're going to notice there's no hydras in their names. So that's your clue that these are all going to be oxy acids. So what you have to do is you kind of have to undo this guy right here. So if I'm carbonic, that means I came from carbonate. And you have to find out what carbonate is. So if we write this out, carbonate is H and CO3. You have to balance your charges. Hydrogen is +1. Carbonate is -2. So when you're all said and done, your formula is H2CO3. Same thing, chromic. There's no hydro on it. It's definitely an oxy acid. Chromic came from chromate. So again, starts with an H because it's an acid. Chromate is CrO4. Check your charges. Hydrogen's +1. Chromate is -2. So when we're all said and done, it's H2CrO4. And very last one here for the acids, hypochlorous. Again, if you undo it, hypochlorous comes from hypochlorite, and you can look that up. And when you write out your formula, you get HClO. You may see some organic ones. All that means, and you may see them written kind of funny here, all that means is that they are technically organic and they have a carboxylic acid. You don't do anything different. You still do the A to the X, the I to the S, or everything. But this right here, this is benzoic acid. And sometimes you'll see it written like this. If you count them up, they're exactly the same. This right here, little section, the COOH is that carboxylic acid. And if you remember, the carboxylic acid looks like this. So that's why you might hear those sometimes. These common acids down here are just ones you've probably seen before or probably heard of before. They're not like anything you have to memorize, but they're ones. This is acetic acid, which is vinegar. HCl is hydrochloric acid. H2CO3 is carbonic acid, which is in soda. HClO4 is perchloric acid, so it's a very strong acid. So these are just ones that you've probably seen or may come in contact with. HNO3 down at the bottom here, nitric, is pretty nasty. It's really good at ripping apart skin, so you have to be careful when you're dealing with nitric. And last thing for this section is just be very aware that when we say salt, we typically talk about sodium chloride, NaCl, but these are just examples of other salts. Technically right here, NaHCO3 is sodium bicarbonate, which is typically known as baking soda, and technically it is also a salt. So there are lots of salts that are present in the world. This is the one we call salt, but there's salts that can kill you, and all it means is that it comes from a reaction of a base and an acid. So just be aware of where that comes from.